So, hello everyone. This is Yu Chen. I'm from the TSCC User Services Group, and maybe many of you have know my name through your questions sent to our ticketing systems. So usually I'm the one replying to your ticket. So for those who don't know me, so I've been working uh for the TSCC User Services Group for almost 3 years, and I'm glad to share my experience I have learned from TSCC with you today. So in today's TSCC 101, as the title suggests, we will focus on accessing and running jobs on TSCC. But before that, we will also learn some very basic or fundamental of the TSCC, like how is our TSCC system looks like, and what is our TSCC allocation system, and what was our file systems and our software environment. Well, that is done uh, through the environment module. And then later we will focus on the job submission and the management. Now we have been using SLURM to submit and manage jobs for how long for most one year 1 year. So uh since we start to use SLURM, we have implemented many new features of SLURM and configure our job schedulers in according to our needs. So I will also introduce those new features. We have added since our last workshop. So you may see many new stuff that was not introduced in our last workshop. So even if you are new users, yeah, older users, I mean experienced users, maybe you have learned some SLURM already. I would encourage you that uh you review our slides and the workshop today to see if you can get those new features. Okay, so let's first talk about the system overview. So this is our TSCC architecture. So we have a condo clusters which has many condo nodes, and also have hotel cluster. We also have a few hotel nodes, and they are connected by our network, and we can access our TSCC systems through the login node. We also have a separate home and the Lustre storage that you will have access as long as you have an account. And then we have a SLURM job scheduler to you to prepare a job script or to run SLURM command to access those condo or hotel nodes. And now TSCC has a Rocky Linux 9 as its operating system. The Rocky Linux is the enterprise ready, providing solid stability with regular updates and a 10-year support life cycle. So we found that this can fit our TSCC very well. So we now have the Rocky Linux as our operating system. Okay, so as you may heard, or if you haven't heard, now you can see that the TSCC operates in two parts: the condo part and the hotel part. So the condo users purchase the hardware most hardware like the CPU nodes or GPU nodes, and then add it to the TSCC cluster. So we call it the condo program, and the hotel users purchase computational time, and then they can use what they purchase to run jobs on the hotel nodes. So most of our nodes on TSCC are the condo nodes. And here are the available nodes. So in the condo program, we have CPU nodes and GPU nodes, and most of our CPU nodes are either Gold, Intel Xeon Gold or Platinum nodes. So each Gold node has 36 core and 256 gigabyte of memory, and the Platinum node has 64 core and 1 terabyte of memory. And of course, we still have many legacy nodes in our condo program. So not all the nodes are the same as listed in this table. So in our condo program, we have A100, A40, RTX A6000, and RTX 3090 GPU nodes. On the hotel side, we also have an Intel Xeon Gold as our CPU node, and we have one A100 GPU node, 16 V100 GPU nodes, and one P100 GPU nodes. So if your group is interested in purchasing hardware, you can you can take a look at our website, and we have more details about how to purchase hardware and our current nodes available. Okay, next, let's have a quick review of our TSCC account. So we have a condo account for our condo users, and of course we have hotel accounts for our hotel users. We also offer trial accounts, which is valid for 90 days. So if you know someone who wants to try TSCC, you can let them to apply for a trial account, and if the trial goes well, we would expect that they either purchase our hardware or the computational time to join TSCC. We also provide training accounts for training purposes, but it's not for trainings like today's workshop, but the trainings held by various labs for different purposes, like the bioinformatics workshop that is specific to a few researchers that using our TSCC resources to run their bioinformatics applications on TSCC. So if you have such training needs, you can consider using TSCC, because we can provide those applications you need, and possibly accelerate accelerate the application performance once you're running jobs here. So to get your TSCC account, please send us email to the TSCC dashboard@ucsd.edu, and let us know who you are and which lab you are from, and we will review your account request and create accounts for you once approved. So to access TSCC, the base tool you need is called SSH. SSH stands for secure shell. So no matter you are using the command line or the GUI, you need to use SSH to log in. So our host name is login.tscc.sdsc.edu. And as I said, if you are using command lines, please use the SSH command to log in. And if you have GUI, like as a Windows user, I'm using the mobile Xterm. I can use mobile Xterm to log in, which is my recommendation if you're a Windows user. So to log in, besides your TSCC username, you also need to have a UCSD AD account now. Then you will need your UCSD AD account's password plus the dual. Dual is two-factor authentication. You need to use your AD password plus dual to log in. And if you are not from UCSD, you still need the AD account's password. So we will create a account for you, a UCSD AD account for you, so you can use its password to log in TSCC. So here is the exact command. Command if you wish to log in TSCC, like the SSH, then type your TSCC username, and then add the host name of the TSCC. Note this is you need to use your TSCC account name here at the login time. But then once you hit enter to execute that command, then you then enter your UCSD AD password plus the dual authentication process. So if you are using mobile Xterm, for example, you have opened the mobile Xterm like this way, then you can either click that start local terminal to open a terminal and then type the SSH command, or you can start a new session in mobile Xterm to enter your username and the host name and then connect. So once the new session in mobile Xterm has started, you just enter the login, the host name and your username, and then you click OK and type your password and do. We will go to our next session about the TSCC allocation. So what is a allocation exactly? So allocation is a block of service unit that allows a user to run jobs on supercomputer clusters. So all TSCC jobs now need to be charged to a valid allocation. So as we have two programs, the condo programs and the hotel programs, we also categorize our allocation to the condo allocation and the hotel allocation. But now the SUs under TSCC are based on minutes. So in the next few slides, you see an SU in minutes. It means what the SUs are measured in the unit of minutes. So this is our programs. Condo users can purchase nodes to join TSCC, so they will have condo allocation, and the hotel users will purchase time, so they will be giving a hotel allocation, which can only be used on the hotel nodes. If a condo user wants to run jobs on the hotel side, the user must to purchase time to get a hotel allocation. Same for the hotel users. So if the hotel users want to run jobs on the condo side, they will need to purchase nodes and become the condo users and then get the condo allocation. So that should be very straightforward logic. So more about the condo, more about the allocation. The allocation can be credited at any time of the year. So that's for the hotel. So basically, hotel allocation is a pay as you go model. So once you purchase the allocation, and the requests in the allocation can be carried to the next year and the next year, and they do not expire. All hotel allocation names are in the form of hotel and then 3-digit. For example, the hotel 101, it's a name of a hotel allocation. So allocations in the hotel 100 are for the individual users, and the hotel 171 is for the trial accounts. So if you get a trial account, you will have an allocation name of hotel 171. And if you are the individual user, that means you are the only user in your lab that is accessing TSCC. You will have a hotel allocation named HTL 100, the hotel 100. So for UCSD affiliates, the minimum hotel purchase is 250. And for other UC affiliates, the minimum hotel purchase is 300. If you are external users, I mean, not from the UC systems, you can reach out to us for the price. So how about condo allocations? So condo allocations are created annually for the duration of your MOU, and there's no rollover of leftover SUs. So each year, the credit in the condo allocations will be renewed, and the condo allocation names may be CSD 3-digit or some other names. The most commonly names are the CSD 3-digit, like CSD 792, and we begin to create condo allocation in the form of CSD 3-digit, but there are other condo allocation names as well. So here are some common questions about the condo allocations, like when is the annual credit date? Now the annual credit date is the fourth Monday of September every year, and it's a credit proportionally when first added to the TSCC. And the answer to this, that is yes. The credit to the condo allocation will be prorated for the first year and the last year. And what's the SU allocation formula? So we will see more details in the next slide. So here is the condo SU allocation formula. We have included the factors of the CPU cores and the memory and the GPU card, if the node you purchase has the GPU card, and then times 16 minutes times 24 hours times 365 days, and allow a 3% downtime. So that's 97% uptime. And then we use this formula to calculate how many SUs you will get every year. So GPU cards have different allocation factors. Here is the list of the allocation factor. You can just plug in those numbers to the formula and calculate. So for example, a 64-core 1 terabyte CPU node is added to the TSCC 25 days prior to the next fourth Monday of September. And I have given the calculations about how many SUs will be created when added to the TSCC and when every fourth Monday of September. Okay, please note the fourth Monday of September in 2024 is September 23rd. So it's very close to now, right? Less than 2 weeks. We will renew your SU in the condo allocation. So what will happen? So TSCC will not be available for running jobs technically begins 11:55 p.m. September 22nd, and is expected to be normal at no later than 12:05 a.m. September 24th. So it may finish earlier than that date. And if it's finished earlier, I will send an announcement to the TSCC mailing list. And also, this would be a very good time to re-evaluate the users in your group to see who has left, who should not have access to your allocation anymore. So you're welcome to report the updated user list to us, so we can add or remove or update users in your group. So how to check your allocation name? So we use this as account manager command to check what allocation you have. So for example, this example is to check my username YCHEN64. So what allocation do I have? So I just type the command as account manager, MGR means manager, and then show, and then association, ASSOC stands for association. Then I specify my username, and then I add the format of the output, which is the account and the user. And then the output will display like this. The account is the allocation I have is the use 300, and the user user is here is my username. Yeah, just want to let you know that it can also show all user accounts in your location. So if you are your manager in your lab at TSCC, you can use this as account manager to show who are in your allocation. But then just I leave a note here. The account in the as account manager command and the other SLURM command, it's the SLURM accounts rather than the user account. So that has been caused a lot of troubles and inquiries. But this is how the SLURM call for the allocations in our mind. So we use the account in SLURM for the allocation purposes. So when running a SLURM command from SLURM, we specify the account. That is actually means the allocation, and the output showing here, like for example, the account use 300 is also about the allocation, not your user account. So next, we are talking about the file systems. So what kind of file systems we have? Here is the overview. We will have our home file system, like the home directory, and each user will receive 100 GB of the storage in their home directory. And we also have a global scratch storage system. The path to it is /tscc/lustre/scratch user, and it's I will have more details about it. And the additional project storage can be purchased from the RDS. And we also have local scratch directories. And here I want you to notice that the default location of your home directory is /tscc/nfs/home and /your username. You may find it's different from many other Linux machines, which is just /home/your username. But this is how we set up our home directory on TSCC. So just keep in mind that. And as I said, each user will receive 100 gigabytes of storage as the home directory space. And please only use your home directory for the source code, for saving the source codes, the binaries, and the small input files. It's not for the high performance IO throughput. So please you use the Lustre or local storage space for your output. So our global Scratch storage file system has 2 petabyte shared space, but each user will have 1 terabyte of disk quota in the Lustre. And please note there's a 90-day purge policy. Policy applies to the data you saved in the Scratch space. So please back up your files to other places in time. So don't consider it a archiving place. And here is some limitations about the Scratch space. So although it's good for the high performance IO operations, it's not designed for extensive small IOs. Like here, if you have more than 200 small files open at the same time, maybe you are testing our Scratch space and make it a high make it the performance worse. So for that case, if you have a lot of small files, small IOs, you will need to consider to use the local storage space on each node. Okay, this is a command to check your disk quota on the Scratch space. The LFS command, you can use this command by yourself to check your disk quota, how many how much storage you have used and what is your quota. If you need more space, you can consider purchasing it from the SDSC RDS group. The project space is not managed by TSCC, but the RDS. And now only the storage operated by SDSC can be mounted to TSCC. And on each node, we will also have local Scratch disk space. So the local Scratch on the compute node varies from 200 gigabyte to 2 terabyte. It's different. It's different on each node, and it's good for writing small files IO. Okay, so if you have like hundreds of files opening at the same time when your program is running, so maybe you can consider to use the local Scratch space at the runtime. And once your program has done, you can just copy your output back to your home directory or back to your global Scratch storage or your project storage, because all files saved in the local Scratch at each node will be purged at the end of running jobs. So next we will take a look how to transfer files from or to the external sources. If you want to transfer files from or to a Unix, Linux, Mac machines that has the SCP rsync or SFTP command available, you can make use of those commands to transfer. If you want to download something to TSCC from a website, So usually you can open that website in your web browser and then right click the link and then copy the link location. And then you can use the wget command to uh to get and download that link. And if you wish to transfer files from the commercial cloud storage like the Dropbox or the Google Drive, you can use the rclone to transfer files. I will not cover any more details about that, but if you need, feel free to ask after this workshop. And we also have globals as the file transfer tool available. As of now, accessing your Scratch storage space with global it's not available, and we will implement it later. But if you have a project storage and want to use globals to transfer files, the RDS team already set it up, and you can reach out to us or the RDS, so we can open that global services for you. And of course, if you are familiar with those GUI tools for the file transfer, like the mobile term itself can be used to transfer files, and more is about the FileZilla. I see many users are using FileZilla to transfer files. That's also possible, and it's also a good tool. So the software environment, TSCC uses lmod, which is an environment module system to build and manage our software environment. So under the current TSCC, not all the available modules will be displayed when running the module available command without loading a compiler. So if you have loaded, you have learned modules somewhere else, maybe you have you were using other clusters before, you may know that the module available command. But on the current TSCC, if you just run the module available command without loading a compiler, you won't see all of the modules available. So instead, you should consider to use the module spider, the module spider command to see if a particular package exists and it can be loaded on the system. And then you can run that module spider command again to find more details about the exact modules you need. I will show this. I will show this in an example in the next 2 slides. And the module paths are different for the CPU and the GPU nodes. So also on TSCC, there are 2 main software stacks. So the first is the CPU software stack, and the other is the GPU software stack. So you will need to load the CPU or GPU modules to access those to access the stack you need. And the lmod lmod system can also can also be used to create your own modules. So you just need to create your own module files and add it to the module path. But I'm not going to introduce this in detail, and you can find how to do it in this at the end of these slides. And here is our software stack. We are using GCC 11, GCC 10.2, and 8.5 and Intel 2019 to build most of our software. And here, the GCC 10.2 is the main compiler we are using to build our applications. We also have a few MPI implementations, which is NVPH2, OpenMPI, and the Intel MPI. And also lists a few examples about the programs under the CPU software stack and the programs under the GPU software stack. So to search a package, here is the more details. When run the module spider command, for example, if I want to know what GCC modules are available, I just run the module spider GCC, and the output will list all related GCC modules. And the output also can tell you that for detailed information about a specific GCC modules, you just need to run this module spider again with the module's full name. Like for example, this for example is directly from the module spider output. It's not added by me. I mean, the module spider output can tell you how to run this command again. So we just choose one of the GCC 10.2 module. So next in this slide, we just add the full name to we just use the full name of the of this GCC 10.2 in the module spider command, and then you see the output. So the output will show that you will need to load all modules on any one of the lines below before to load that GCC 10.2, and you will see that it's asking you to first load the shared module, and then you need to load the GPU module. So that indicates that this GCC 10.2 module is built under the GPU software stack. So once you load the shared and the GPU module, you then can use load that GCC 10.2. Okay, so to load a module, you just use the module load command and specify the package name, and unload it, use the module unload. So that's very simple. If you want to load the exactly version, you just give the package version after the package name. And now note that modules will load any dependencies for a module when that package is loaded. Okay, if you wish to see what modules are loaded in your current user environment, you just run the module list. If you want to purge all of the loaded module, you just run the module purge. Still very easy task. And as the example shows here. Okay, that's about the TSCC overview, which is about the login account architecture modules, and now we will focus on the job submission and management. We will first learn some base job partition and QoS concepts. So we are using the SLURM as our workload and resource manager. This is a very popular job scheduler, and I think most of the classic HPC clusters nowadays are using or considering to using SLURM as the job scheduler. But before we are running any jobs, here's a reminder. please don't run your computational programs, applications codes on the login nodes. So even even for some tests, because those login nodes are meant for login. So besides login, you can use them for file editing, simple data analysis, or other tasks that only use a minimal resources on the login node. And also if you have some tests on the login nodes, maybe the performance will be different when from when you are running the test on the nodes in your production run. So your test might not be accurate on the login node. Please don't run those tests or any other production runs on the login nodes. So in SLURM, we have job partitions. As the SLURM partition is a set of nodes that a job can be scheduled on. On TSCC, the partitions for each job submitted to SLURM differs in the hardware type, which is the main difference. And the partitions also differ in the maximum job work time and the job charging weights, which is related to how your job will be charged. Now, if you are in the hotel program, you will have two partitions, which is the hotel and the hotel GPU. And if you are in the condo program, you will have a few more partitions available, which is a condo, gold, platinum, and a few GPU partitions. So how these partitions differ in the hardware type? So here's more details. So in the hotel programs, the CPU nodes are added to the hotel partitions, and the GPU nodes are added to the hotel GPU partition. So that's should be easy to understand, but it's a bit more complicated for the condo program. So on the condo side, the CPU nodes are added to the condo partitions. If the CPU node is a gold node, then it will also be added to the gold partition. So on the other hand, if you have a platinum node, then that platinum node will be added to both condo and platinum partition. How about the GPU nodes in the condo? So the GPU nodes are added to one of the GPU partitions above. So say if you have a A100 GPU node, then it will be added to the A100 partition. And if you have a RTX 3090 node, then the node will be added to the RTX 3090 partition. There's no condo GPU partitions, just as listed here. So we don't have condo GPU partition. If you wish to know all the current partitions, you just run the sinfo command. That will give you more information on the partitions. Once you run this command, you'll see how many nodes are in each partitions and their status, whether they are idle or whether they are allocated or in the mixed state. Some nodes are done, and then it will also be listed there. If you wish to track the node in a specific partitions, you can specify the partition name. You can specify more than one names in the -p option in the sinfo command. Okay, so next is about the SLURM job quality of services. We also refer it as the QoS. So what is a QoS? QoS for each job can affect a few features of the systems. So the QoS can affect the max job work time, and it also affects the job scheduling priority, and also the job preemption and the job limits. And as a user or as a user group, you can have multiple QoS. And here's the list of the QoS you may have. In your if you are a hotel user, you will have the hotel and the hotel GPU QoS. If you are a condo user, you will have a condo GPU, and the one or more than one of the HCG, HCP, and the HCA QoS. The HCG, SCP, and the HCA are the hardware type QoS that stands for this. So HCG stands for HPC Condo Gold. It's only for the condo groups who owns the gold node. And similarly, the HCP is HPC Condo Platinum. It's only for the condo groups who owns the platinum nodes. And the HCA is for the condo groups who owns the GPU nodes. Of course, if your group both owns both gold and platinum nodes, then you will have HCG and HCP QoS. And you can also use the account manager command to show your available QoS. This account show association command shows what QoS I have. I just need to add the QoS as the format in this command. Note I add the QoS, then a person sign and 50 because I have multiple QoS and I wish the output to display to be displayed in a longer format. So once I run this command, I will say that I have hotel GPU and a normal QoS, and maybe it's not very updated because I also have condo and a condo GPU QoS. If you wish to get more information about a certain QoS, you can use the account manager show QoS command, and then give the format you want to show more information on the QoS. So here is the example about the hotel QoS. I added a few format in the account manager command, and it will show the maximum work time and the maximum resources the hotel QoS limits. So we will see the more details about the limits in the QoS later. Okay, so here's a very important thing I think every one of you should learn, because I have been asked here about this many times, and so I decided to add it to our workshop. So you get to know what QoS you have. So and then you may want to know with the QoS you have, which partition you can submit job to. Now I'm having this in a table showing the QoS and the partition mapping. So this is the table. So both partitions and the QoS must be specified when submitting jobs to TSCC. So that's mandatory. If you have a QoS, if you wish to use the hotel QoS, then your job should be submitted to the hotel partition. And if you have wish to use the hotel GPU QoS to to run GPU jobs, then your job should be submitted to the hotel GPU partitions. Same for the condo and the condo QoS and the condo partition. But if you wish to use your own QoS that is assigned to a group like the HCG, HCP, or HCA, this is the partition you can submit. So for the HCP QoS, you submit your job to the platinum partition. If you have a HCG QoS and wish to use it, then you must submit jobs to the gold partition. And if you want to submit the condo GPU submit jobs with the condo GPU QoS, you can choose one of the GPU partitions to submit your jobs. And if you are assigned HCA QoS, then you need to submit your jobs to the partition where your group's GPU nodes is in. So here is the more information about the hotel QoS configurations. So if you are hotel users and you will have hotel and hotel GPU QoS, then in this table I listed the max time per job which is configured in the hotel and the hotel GPU QoS, and also I listed the maximum jobs submitted per group. Group is the all users in your group in your location will share this limit, and also maximum CPU node and GPU per group, and also maximum CPU node and GPU per user. And these are the limitations defined in the hotel and the hotel GPU QoS. And note this maximum jobs submitted per group also applies to the job array. I mean, on TSCC by default, the job array can specify can specify 1,000 jobs in the array. But if you are hotel users, you are using hotel or hotel GPU QoS to submit your jobs, your job submission will be limited to 196. And here is the condo QoS configuration. So in the condo and the condo GPU configurations, the maximum wartime per job are not defined limited in the QoS, but I found that they are defined in the condo and the related GPU partitions. And I also listed the maximum wartime here for your reference, but they are not defined in the condo and the condo GPU QoS. And please note, if you submit jobs with the condo or condo GPU QoS, your jobs will be considered as a condo or condo GPU jobs, and they become preemptible after 8 hours, plus the 30 minutes grace time. So that means if if your job condo or condo GPU your job submitted with the condo or condo GPU QoS has been run more than 8 hours, and the other jobs submitted with their HCG, HCP, or HCA QoS are coming and need to use the node your jobs is running, then your jobs become preemptible. Okay, so what's the more about the details of the HCG and the HCP HCA QoS configurations? Because now on TSCC we don't have home queues or home partitions, as some experienced users may know that if we had home queues before, but we don't have it anymore. So the purchase node will be added to gold, platinum, or one of the GPU partitions. And then the HCG, HCP, and the HCA configuration limits the total resources your group can be used when submitting jobs to the gold, platinum, or GPU partition. And then those jobs submitted with the HCG, HCP, or HCA are not preemptible. And they have a wartime limit of 14 days. They have higher priority to start, and where the will label the node. This is an example. So if a PI purchased 836 or 256 gigabyte of RAM nodes, then once the nodes have arrived to TSCC, they will be added to the gold partition because they are all Intel gold node. That we will recognize that PI contributes 288 CPU cores, 2 terabytes of RAM in 8 nodes to our gold partitions. Then we will assign the HCGQS to the PI's group and for their group members to submit jobs. And the total resources limit for the GIS for the group's gold job submission is CPU equals 288 or memory equals to 2 terabytes or the 8 nodes. That means if the job submitted with this HCGQS has reached to either one of them, either CPU or memory or node, then the other job submitted with the same HCGQS will have to wait in the queue in the partition until the previous job have finished. Okay, so what those jobs submitted with the HCG, HCP, or HCA will label the node running the job. So what's that labeling? That's called the multi-category security MCS labeling. The label makes sure that if a PI's group has one job submitted with their QoS running on the node, the entire node will be labeled by their group name. So no other group's job can land on the node. So as a result, only jobs from the PI's group can use the rest of the resource on the node. To be more accurate, only jobs submitted with the same HCG, HCP, or HCA can use the rest of the resource on that node. So we apply this MCAS label for reasons, and it can help SLURM assign jobs more easily, and it can enhance the security access. So if you wish to know more information on the partitions, this scontrol show partition command can show you what to have what a partition can give you. So in this example, we are showing the scontrol partition. Actually, it's a hotel partition. From the output, we can see that the allow QoS is the hotel. That means only jobs submitted with the hotel QoS can be submitted to the hotel partition. And the maximum time is 7 days, and which nodes are in the hotel partition, as I also highlight here. And the last in this output shows the billing weights of each CPUs and the memories on the node when you are running jobs in the hotel partition. So that's what we are going to introduce in the next few slides about the job charging. Before that, I will see if we have any questions.
There's no additional questions. Well, we have the team in the back end answering some of those.
Okay, that sounds great. Sounds great. Sounds great. Thank you. So let's move on the job charging. So I think that most of you might be not that interested in the job charging as you are not managing your allocation. But here, if you know how your job will be charged, you will be more careful about using your group's resources, right? So you don't want your PI know that you're using too much resources, so then much more than you should use. So here is the formula we used for job charging. So the job charging formula was set based on the hardware type and cost. In this formula, we consider how many CPU cores you are using in the job and how many your request actually itself, how many CPU cores you request for your job and how much memory how many gigabyte of memory your job has requested, and if you are using GPU card, what type of GPU and how many number of GPU cards you are using, and then we times those charging we added those charging factors and then times the job runtime in second and divided by 60. So here is a list of the job charging factor. If your hotel users or hotel GPU nodes have the same charging factor, which is 30. So this is an example of the job charging on the condo side. So a researcher in the condo program wants to run a job that requires 16 CPU cores, 32 GB memory, and one A100 GPU card for 2 hours. So the core charge factor will be 16 and the memory charge will be 6.4, but we will use 6 because SLURM will only take integers for these calculations. So the GPU charge will be 60. Now we add them up and consider the time. So when job finish on time at 2 hours, then here is the result of the showing how many SUs the job will be charged. If job terminates earlier, say after 15 minutes, then less SUs will be charged. So the charge is based the real time this job finish. Okay, for the same numbers, but the job is running on the hotel side. So a researcher in the hotel program running the same example jobs, then the charging factor for the GPU for one A100 GPU card is just 30. So we lower that number and change it to 30 and add all charging factors to up and then times the real time and we'll get the SUs to be charged after 2 hours or after 15 minutes in this example. If you want to check the SU balance and the usage, yeah, as we discussed earlier today, there is a very useful script on TSCC to check the SU balance and the usage. And here is an example to check a user's allocation and the usage. So the command is called TSCC underscore client dash u, and then you put your username here. And I'm in my username, my account as the example. So here, once I run this command, I will see a header, the header of this output showing some basic information about this allocation, and then the last two lines of the output are the allocation and my account about the allocation and my account. So the first use 300 is the allocation name, and in each entry there are a few columns like the usage, allow, user, account, balance, and what's the usage? The usage is the SUs, the group, or the users has used up, and the allow is the total SUs allocated, and the user is the usage divided by allow. So it only applies for each user. I mean, in this example, if I divide my usage to the allow, I will get the 1.46%. And the account in the account column is the usage of the user divided by the total usage. So I get how this example how to get the 95.7%. And the last column balance is the remaining balance of this allocation or of this user. And this script can also show the group allocations and the usage for all users in one allocation. So you just change the options to dash capital A and the allocation name. Here I use my allocation as the example, TSCC-A use 300. I will see lot my colleagues usage and the balance available to them, and or still all those columns that have the same meaning of as we introduced for checking per user's allocation. Okay, so here are more tips when using TSCC client. First, you must load the SDSC module to your user environment to use this script. And also you need to you can it's optional. I mean you can end the start or end the date of your search, and also note the allocations in the hotel 100 is for the individual users, and hotel 171 is for the trial account, and so they are individual allocations. So if you have either hotel 100 or hotel 171 and run the TSA client, and you find a lot of users you don't recognize, and you please don't be panicked. And they are not they have the same they have the same allocation name as yours, but they are not in they're not in the same group allocation as yours. So you just all have your individual allocation name allocation, but just use the same name. So that's about the TSCC client script. Okay, so finally we are talking about the job submission. So there are two types of jobs you can run on a cluster. So either interactive job or batch job. interactive job, set up interactive sessions on the compute node. So you can run your programs interactively. You can type your command and then hit enter and see the output of your command. But just sometimes you want to make sure that if you see some errors or you found something need to modify, you should be in front of your laptop and do it by yourself. The purpose of the interactive job usually is for testing, debugging, or use some GUI. And we also have batch jobs, which is usually for the production run. And once you submit your batch job, and the system will take care of everything. So you don't have to worry about it. You can even log off from TSCC and leave and just wait for the job to finish. But once you submit a batch job, usually it will be hard to modify the parameters or the input. Okay, in SLURM, interactive job can be submitted with the srun command. So I list many options you will use when submitting SLURM interactive job, like the -t is short for the time in the format of hour, minutes, and second. You can also add the days before the hours if you want, but you can just use the hour, minutes, and the second format. And in the srun command, you also need specify you can also specify the -n, which is short for nodes, how many number of nodes you want, and -n, the lowercase n, short for n tasks, which is the total number of tasks to run jobs on, and the -z, short for the CPUs per task. This -z option is used for the multi-threading jobs. So it's very common to see if you have a multi-threading program running before running the program, you need, if you want to start a job, then you should specify the -z for the multi-threading. And the -a is short for the account, which is actually your allocation name. So that's a very common mistake I see the user made, because the account is SLURM commands like srun is the SLURM accounts. So please add your allocation name in this option. And the -t, -n, and -a are all required or prefer to be specified when submitting jobs. And same for the partition and the QoS name. Actually, you are required to specify the partition and the QoS when submitting jobs on to TSCC. If you want to use the GPUs, you should also specify the dash uppercase G, which is short for the GPUs, and to tell SLURM how many GPU nodes, how many GPU cards you want. You can also specify memory, and I will give you more details about that. And if you wish to use the X11 forwarding to use GUI, you should add this -X11 option to your srun command to make sure that your srun command can start the interactive session on the node, you also need specify the -pty. So the first task of this command will start in in a new terminal. No, not new terminal, in a new pursuit terminal. So this srun command must be end with an executable. So here in this example, I ended with the bash that tells the scheduler to open a batch session once the job starts. So here's the command looks like in the terminal. How the command looks like in terminal? The srun, then -n1 and -n8 and memory 20 GB. Here we are specifying in the unit of the memory because the default unit in SLURM is measured by on TSCC. So you must specify the memory if you wish to use 20 GB. And then the time, partition, QoS, and the allocation name, PTY, and the executable. Note once the job has started, you see the node name change here. So before you are running this job on the login node, so you will see the login 1 because that's the host name of the login node. Once the job has started, you will find that you are on one of the compute nodes you have. So here is the TSCC-11-70. So that has been changed. And also note that in SLURM, the job starts in where the job was submitted. So that's a feature of SLURM. So you don't have to change your directory to where you submitted. If you wish to run MPI in interactive sessions, you must specify the -- overlap because here is the way to once the job has started. Here's the way to start the MPI run. So we still use the srun command to start the MPI calculations, but we specify the -- overlap option. Otherwise, the srun will ham. So then we specify how many MPI process we need, and then the MPI executable. And you can find a MPI executable example in here. The CM shared examples SDSC TSCC2 MPI. I have prepared an example there. You can start an interactive job to run the example, or start the batch job to run it. So here are more questions. Now here are more details about the CPUs allocated to the job. So I list the maximum CPUs per node you can add in SLURM here. Now if you submit jobs to the hotel partitions, the current maximum CPU per node is 28. And for the condo, because those platinum nodes are also in the condo partition, the maximum CPU per node in the condo partition is 64, which is the same as the platinum partition. If you submit jobs to the gold partition, so the maximum CPU per node will be 36. So your job can the CPU cores requested by your job cannot exceed the total number of CPUs on the node. So here these two example jobs can start because they ask equal or less than the maximum allowed CPUs. If so, the first example is asking two nodes and in the condo partitions. So two nodes in the condo partitions has a maximum CPUs of 128. So if your job requests 128 tasks in the lowercase n, then the job can start. And if your job starts like two tasks and 60 CPUs per task, that is 120 CPUs in total in the job. So that's also allowed for the two nodes, because the two nodes in the condo partition has 128 cores. But the last example cannot start, and the SRun will give you an error because because you have requested more than the node has, right? So in the condo partition, you can have you can there are 64 CPU cores per node. So if you ask for 129, it won't work. Even if you change your nodes to 2, I mean, you specify the dash capital N to 2, it still cannot start because two nodes have 128 cores. Okay, so I would like to 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 add more information about how to allocate CPUs to the job. Although requesting more nodes can increase the maximum number of CPUs to the job, you need to ensure your program can run on multiple nodes. It's very common to see that your program cannot run on multiple nodes, especially on TSCC, because most of the application is running here at the bioinformatics applications, and I found many of them actually cannot run on multiple nodes. So if you're asked more than one node and then run your program, then you may find only the first node is running your program, while the other nodes are idle actually. So pay special attention to double check whether your program can run on multiple nodes. And also you need to try use CPU from the same node. As here, I have an example. So to use a total of 8 CPUs, it's not recommended to request 4 CPUs on 2 nodes. Actually, this is also very common. I see the users have. I don't know why you set you prefer to set it in this way, but why not just try use all CPUs or 8 CPUs in the same node, like specifying dash n capital N in 1 and the lowercase n in 8, so that in that way all of the CPUs will be from one node, right? Okay, next I will talk about the memory allocated to the job, and here are some common questions I got. So like, what's the default memory allocated to the job? Answer is 1 GB per CPU core. And what's the default unit memory in SLURM? As we seen in the interactive job submission, the default memory unit is a megabyte. So if you are specifying memory, you should specify it in gigabyte. So you can choose GB or lowercase g or GB. So either one of you can work. Can user specify memory? Now the answer is yes, but you need to make sure you're asking appropriate memory to ensure it can meet your program's requirement and not wasting your computational resources. And what's the charging factor of the memory? The charging factor is the 0.2 per gigabyte. So memory, we are charging charging memory usage here. And what's the maximum amount memory user can request? So I will give you more details about the maximum memory you can request. So remember, you can use the -- mem option to specify memories on in your job. But this option is for specifying memory on one node. I mean, that's according to my test on TSCC, it's for specifying memory on one node. So you should not specify more than the memory listed in this table. For example, you are submitting a job to the hotel partition, you should not specify more than 187 gigabyte memory in your SLURM or in your job scripts. I listed the partitions I have tested here. So note some gold nodes may have more than 251 gigabytes, but there are only a few of them. So I would suggest that it's recommended to if you wish to use the maximum memory of to the gold partition, don't specify more than 251. And of course, still requesting more nodes can allocate more memory to the job. For example, if you ask 2 nodes in the hotel partitions and specify memory as 187, then the memory allocated to your job will be times 2, so doubled. But however, please still ensure your program can run on multiple nodes, which is it's not common on TSCC. So the GPU allocated to the job can be specified in the dash GPUs option. So for example, dash GPUs 2 will allocate 2 GPU cards to the job. If you request multiple GPUs, also please ensure your program can run on all of them. Don't let the first GPU cards running while the rest of them are idling. And here in this table, you will see that how many GPUs are there on per node. So I have a list here for your convenience. Once your GPU jobs has started, the allocated GPUs are references by this CUDA visible devices environment variable. This is very important because many programs like the machine learning program or the deep learning program are using this environment variable to get to know which GPU devices the program can use. So if you don't specify the dash GPU's option and start job on the GPU node, your program might not run correctly. And please don't manually set this variable, because that won't help for you or for other jobs, for other users' jobs. If you are setting this and then another user running their program on the same GPU card, then your programs will running on will landing on the same GPU card. So that's causing slow performance or even crash for both of your jobs. Okay, so before going to the batch job, are there any questions? Let me see the chat.
There are no additional questions at this time. Trevor
Okay.
has been kindly answering them in the back.
Okay, thank you. That's great. That's great. Okay, so let's move on to the batch job. Here, on TSCC, the batch job can only be submitted with the sbatch command. I know that on other clusters, the command might be different. But here the command the batch job can only be submitted with sbatch command. And many new users are submitting their jobs with srun, but that's not correct, and their job will fail immediately. And most of the time they have no idea why the batch job failed when submitting with srun. So with the sbatch command, it's easy to submit batch job. You just need to prepare a job script and then run sbatch, following up with your batch command. That's great, and you should carefully prepare your job script. That's very important to know how to make sure the job can be submitted and run successfully. So here is an example on TSCC. I saved this job script on TSCC. You can find this script on once you log in, and then go to the CM shared examples, SDSC, TSCC2, open MP, and you will find the job script open mp-slurm.sb. In this job script, I highlighted the first session because it's about the job scheduler can handle the job submission. The first session highlighted in green most starts with pound sign sbatch is from SLURM, and it can tell SLURM how to submit and the job, how to write the standard output and input, how to send the email if you want to receive an email at some time point of the job. But you can see that the many options have been introduced in the interactive job submissions because it's the same. But what's new here is you can add more options in the job script. Like you can specify a job name by -J, and you can specify where your standard output of this job and standard error of this output, and you can add your email address to this session. So once the job ends or once the job starts, some other conditions, then you will get notified. The second session of this job script about how to use the resources allocated. So here I just change on my modules, load all necessary module, and then began to run this OpenMP example. And if this is a GPU job, what's different from the last example is the -G option. You should specify how many GPU cards you need, and of course you need to change your partitions and the QoS to the proper GPU partition and with your GPU QoS. And still, the next part is about how to use the allocated resources. In this example, we are running the Amber simulation in on the GPU with one GPU card, and here you can find that example here in the same shared examples, SDSC, TSCC2, Amber GPU. and you can find the job submission example. And we have prepared more examples under the same directory, but you should not run those examples directly there. Instead, please copy the entire application directory to your own space, like to your Scratch space, and from there you can edit the job script and execute the batch job. Because you see that in those example, I I have I have specified my allocation name. Or if you are not a hotel user, but if you are a condo user, you should also change your partition name and QoS to your own. So before submitting those jobs. Okay, so the last part is about the job monitoring. So once we submitted our jobs, usually you would expect it can run, but that's not always the case, right? So sometimes it crashed early, or sometimes it is wrong. It couldn't give you output. So once your job has been submitted, or even it's running, please don't just leave. Instead, please monitor your job to see if you can get the output you expected, or if the node looks good. We have a few commands from SLURM that can help you to monitor your job. The most important one, I think, is the SQ command. So the SQ command can check details on your jobs or submitted by you. So you just give the -u option and your username. The SQ command can list the output about all jobs you have, no matter they are pending or running. So by default, the SQ command can show you the job ID, which is of your job, and where your which partition your job is submitted to, and the name of your job. If you are submitting an interactive job, then you will see the job name is called bash, or some other executables you use in your srun command. And then you can see the username and the status of the job. By default, you will see some shortened status, like the PD means pending, R means running, and C means completed. And the time is the elapsed time since the job start running. And you will also see the work time limit, the nodes, and the node list. If the job cannot start or pending for any reason, so then the SLURM can show what's the reason, and help you to identify why your job is pending there. Okay, so SQ can be used with other options. So maybe this is more useful when you are a system admin, like check the details on your group's job. You can use the SQ dash big A, and then follow up by your allocation name. You will find all users in your allocations jobs, no matter they are pending or running. If you wish to check the details of job in certain partitions, you can use the SQ-P. And if you want to check the details of job on certain nodes, you can use the SQ-W. That in this example, if I want to check the four nodes, four nodes, which are TSCC 11, 29, 30, 31, 32, I can just write the SQ-W in and the node in this format. And you can also customize your SQ output with this SQ format 2 environment variable, because the SQ format is another environment variable you can use, but the SQ format 2 is preferred and recommended by SLURM. So in this example, this is my SQ format 2. I specified how many format how many output should be listed in the SQ commands, and how long each result should be. As I highlight here, I added the QoS because this is very important and common on TSCC, and the time limit, number of CPUs, minimum memory to use, and all defined in this environment variable. And then if I run the same SQ-W command, the output will give me more output in the column. So you can find more about this format on the SLURM document. Okay, so besides SQ, you have other SLURM commands to monitor your job. So actually the first command is not more for job monitoring, but if you want to cancel your job, you can use scancel and then add your job ID. And you can also check the details of your job, use the scontrol command. As long as you know your job ID and your job is running, you can or pending. So you can use the scontrol show job and your job ID to see more details about your job. And also you can use the saccount command to check some status of your jobs, like the elapsed time of a running or finished job. I found this saccount command is very useful. Even the job has finished, you can still use the saccount command to check the status of your job. As long as you know your job ID or username, you can use saccount. And please pay close attention to the CPU and the memory consumed by your job, because this will affect your job's performance. So if you find your job is running slow, or your program is takes much longer time than you expected, and maybe you can check whether you can whether you can whether your job is overutilizing or underutilizing the resources it requested. And when you have a job running on the nodes, you can SSH to the command to the node running your job, and then use some Linux commands to check the node status. Of course, and you can also get more information about the programs you run. Once you like this command, the Linux top command, once you run the top command, you can see the load average of the node, as well as many other useful informations about the node, as well as your program. to make sure that your program is running properly. You can also use the free command once you are on the compute node running your job to check the memory usage of the node. If you are running a GPU job, once you are on the GPU node, you can run the NVIDIA SMI command to check whether your program runs on the GPU card or not, and how many GPU memory has been used. And here is a list of the SLURM environment variables. And of course, you don't have to remember every one of them and to know how to use every one of them. But I highlighted two of them, which I think that it might be useful when you are writing some programs in the job script. The first one is the SLURM job ID. So once the job has been submitted, no matter it's pending or it's running, you should have a SLURM job ID variable available, and you can use it to for different purposes. And also you can use the SLURM submit directory, directory to know where to reference where your job is submitted. If you have used the other job scheduler before, like the PBS job scheduler, here is the table about how to submit jobs in the SLURM versus how to submit jobs in the PBS. Just a quick look for your reference. Okay, so I think that's pretty much about today's TSCC 101 job submission and management. What's happening next is we're preparing more trainings to help users get familiar with TSCC, and usually we will have a TSCC training like once or twice per year. And each training will have most up-to-date information because we are keep adding or modifying our systems. We will add those informations to our next workshop. So some of them might be very useful or important to know. So that's our plan. So next year we'll definitely have more TSCC trainings. And also we are also developing the TSCC Open On Demand portal. So if you haven't, if you don't know what's that Open On Demand portal is, so it's like a web portal for you to log in from the web browser, and then it's a GUI, it's a graphic user interface. Once log in, you can also choose to run in the command line interface in the portal, but it also provides a few GUI features for you to run and to submit jobs more easily, or for you to manage your files on TSCC in the GUI. So so just keep an eye on our announcement, and once we are done, we will send out an announcement about this. Okay, more information about how to contact us. So any questions after workshop, you can send it to tscc-support@ucsd.edu, and then there will be a ticket generated, and all of my colleagues can receive your questions, and we will answer your in time during the working hour. And here is our website. On our website, we have lots of useful information, including our update, our new user guide, and we also have can have a have partnerships with different research teams that require ongoing customized support for their projects. So if you're interested in any research collaborations, you feel free to reach out to us. So that's what I have today. And at the end of this, we're not going to practice TSCC job submission today, but I also included how to submit jobs, submit interactive jobs and batch jobs for you to get familiar with our systems. If you are not familiar, I recommend it to learn and practice those codes after the workshop. And thank you. Any questions?